Okay, let's start slowly, because we only have 50 minutes. Can you hear me loud and clearly, all in the last rows? Can you hear me? Yes? Good. Hi, welcome everyone. Thanks for taking your time to this talk about microfrontends. Who has ever heard about the term microfrontends? Cool. Who used them in productions? Who regrets to use them in production? Okay. Okay, I will ask this question again in 1 year maybe. Yeah, welcome to this talk about microfrontends. First things first, my name is David Leitner. I'm working as a technical expert for a company called Core Technologies. So what I actually do as a technical expert, I try to help people and teams and projects getting their stuff done, building things right, and more important, actually building the right things. So I move from project to projects and try to help them, mainly in the front end these days. So I have a huge background, but I moved to the front end a couple of years ago, and I do a lot of JavaScript actually. I also do a couple of things around the community, as we all should do in this awesome community of software engineers. And actually, that's it. And I would have liked to start this talk with a classical definition about microfrontends, what microfrontends are and why we use them and why we should maybe not use them. But as usual in software engineering, we do not have a common understanding about things we use on a daily basis. And at least in my opinion, there is no common understanding what microfrontends really are. I like the definition from Michael Gears most. He says microfrontends, the idea of microfrontends is to extend the concepts of microservices to the front-end world, right? And this sounds easy and this sounds simple, and that's why I like it. But as so often, if we just move concepts from one side to the other side, it usually has some problems, and those problems we also have in microfrontends usually. So let's start first with the classical blueprint architecture, as I see it mainly in projects I work or I'm involved in. And this blueprint architecture usually some kind of microservices, right? I have a couple of them. Then we have some kind of single page application, Angular, React, or whatever, and in between we have an API gateway, right? This is how it's roughly done in 90% of the projects where I work with. And that's fine, and that's the first secret I already want to tell you. In 80% of the use cases, that's fine, right? I don't want, just a disclaimer up front, I don't want you to go home from this talk and say, hey, we want to do microfrontends now because we had this great talk from this great speaker who told us to use microfrontends. Now, no, in 80%, all the stuff you will hear today is not useful for you, right? In 80%, this is totally fine. This is a good architecture. And I tell you, I'm in the mood of telling you secrets today. And there's a second secret I can tell you. Also in 80% of the use cases, that's fine, right? But I'm not here to play microservices today, not today. So let's assume we are doing microservices because we really have benefits from doing them, right? And in comparison to microfrontends, with microservices we have the big advantage that they are clearly and well defined. There is this great book from Sam Newman, Building Microservices, and he clearly says microservices are small and focused to be autonomous, right? So we build small and focused services for one reason, to be autonomous, right? And that's it. So that's the definition of microservice. So even the definition of microservices is somehow micro. And the question occurs, why do we want to be autonomous? And there are roughly 6 reasons. Maybe there can be more, but I try to group them in 6 reasons. Also Sam Newman did so. And if we take those 6 reasons, we will find out that the first reason why we want to be autonomous in our microservice architecture is because we want to have independent deployments, right? That's the obvious one. We build independent services because we want to ship them. We want to deploy them independently. We have independent life cycles and lifetimes in our microservice architecture, right? The second one is that we want to have distinct operations. So our services start on their own, they live on their own, they die on their own, they restart on their own, they have persistence on their own, they are autonomous when it comes to operations, right? They can really run fully autonomous. That's the second reason, which brings us a lot of resilience and stuff like this. The third one is that we can be technology agnostic. The important term is here we can, right? I mean, we don't have to, but usually it's quite good that we can use the technologies and tools which fit best for our problem. And microservice products this possibility, which is quite interesting in some use cases. And we depend on small interface surfaces, right? This was one of the main ideas from Sam Newman, also Greg Young said this later. Then we build services that we can easily decouple them and we can even remove them easily, right? So we just have a small number of exposed functions actually, where we say, okay, with these functions you can talk to my microservice, with these HTTP endpoints or whatever, you can talk to our microservices. So we have a really small interface surface between our services, which brings us a lot of decoupling, of course. Sorry. We can model around business domains. I mean, this is a huge topic, this whole Blue Book stuff. We could talk and whole talk about this, but the idea is roughly to bring teams about services, and we see that people start to do this, and it's a really good thing, because you can really get to these cross-functional teams without all these bottlenecks. Last but not least, we support parallel development, right? That's why we usually do it, because we build tons of software each day. Software eats the world, so we need to parallelize this stuff. And microservices are usually a useful way for companies to support parallel development, right? So why do I tell you all this stuff about microservices? Huh? You're not in a microservice talk here, you're in a microfrontend talk. Well, if we take a look at our blueprint architecture here again now, we see again the single page application. And if we think about those reasons I just told you and take a look at the front end, we will find out actually that we lose a lot of the advantages we gained with microservice architectures on the front end world, right? So on the front end, we lose a lot of them. Because if we take a look, for example, of independent deployments, we usually don't have them. If we build one big front end, we can ship it or we cannot ship them, right? We can work with feature flags and we can work with feature toggles and all this stuff, but usually we have one big deployment. We cannot really split deployments for features. We deploy our front end or we don't deploy our front end binary. We do not have distinct operations, and mainly in JavaScript this can be an issue. So I already mentioned that I work with JavaScript now for a couple of years. I came from a Java backend area, and even if I'm working with JavaScript these days, I can tell you that it's quite big, the chance that you do something wrong in JavaScript, right? Even if you use TypeScript and stuff like this. So people sometimes ask me, David, why did you move to JavaScript? Why do you invest so much time in building JavaScript now, right? JavaScript applications. Why do you just don't stay with Java or .NET, right? It was much easier. And well, I don't know. Somehow I like the language, and sometimes I say to them, yeah, you know, sometimes if I'm doing JavaScript, I just say, I don't like this stuff, right? But then usually I do not know what this refers to, right? That's the good thing in JavaScript. So even if you have a lot of experience in this stuff, distinct operation would be quite useful, because you make mistakes. And if you have this one big single page application, and if you fail somewhere, right, the chances are quite high that your whole application will fail the front end. We cannot be technology agnostic. This is a big point, in my opinion. I was at the NG conference, I think in 2000, I don't know, 12, 13, something like this, in Paris. This is the biggest Angular, or was the biggest Angular conference back then. I'm not sure if it still is. And there was a keynote from Google developers, Google engineers. Everybody was really looking forward to this keynote. Me too. I was sitting there and saying, yeah, finally Google keynote. I will go there and I will find out what's the latest features about AngularJS. Actually, the only thing they said is, AngularJS, well, it's built up on old standards. We cannot really maintain it anymore. We will do Angular now. So we will fully mess up everything. And there we realized that it would be good to be at least somehow technology agnostic, also in the front end, even if it's very hard, because the things are changing very often and fast. But we didn't have this, right? And we also usually don't have those small interface surfaces, because we build one big monolithic application. Of course, we also can slice our applications, usually smaller, but we don't have this strong independency. What do we have for microservices? And last but not least, and this is usually the issue when people come to us and say, hey, we want to go into this micro-frontend approach because we cannot support parallel development anymore, right? Because we have 6 Angular developers now in our Angular application. We put 6 more into it, it's not getting fast, right? Fred Brooks already knew this 15 years ago. I always tell him the same thing. You need to slice this stuff smaller, right? And this is when people tend to call a frontend monolith is born, right? This is what the so-called front-end monolith is. And how do we usually kill monoliths these days? We kill it with something that starts with micro. And then people say, okay, let's go for micro frontends. And that's it. Usually this is where most of the talks about micro frontends end, right? So we should just slice our single-page application in smaller chunks. That's what we should do. And this is what we tend to call micro frontends, right? Well, there's one fundamental question here on this slide. How do we actually slice this stuff, right? Who has an idea? How could we slice our application to smaller chunks? Nobody? Okay, I will tell you. I will try to tell you at least, yeah? Well, there are multiple possibilities. The first one, and you can see this in the title of this talk, is to really go for fully end-to-end verticalized systems. And I always use this Amazon domain. I never worked in this domain actually, but I think it's quite understandable for everyone, and it's complex and simple enough to get around the head with this one. And so I use this Amazon domain where we have a catalog where you can look for products. We have an ordering page where you can look your current orderings, and you have a profile page where you can take a look at your profile. So we slice our application really from persistence to front-end, end-to-end verticalization, right? This is what sounds really interesting. And the great thing about this is that we just link those applications usually with Hyperlink. And this is what we tend to call the Hyperlink collected applications, or Hyperlink approach. And this one is really easy because you have now 3 different front-end applications and you just link them with hyperlinks. Well, we have a couple of issues here. Oh, no, actually we have a couple of advantages first here, right? We have independent deployments again. That's what I mentioned earlier. We can deploy our front-ends independently. We have distinct operations, so each application can run on its own, can again die on its own, can maybe even restart on its own. We are technology agnostic, so we could build the catalog in React, the ordering in Angular, and the profile, I don't know, in the framework of we can do this. Again, we don't have to, but actually we can do. Build all those applications in different frameworks if we want that the user needs to download a new framework every time he switches the page. And we have small interface surfaces. We just have hyperlinks between those applications, right? We couldn't decouple our application more like in this approach. We can model around business domains, and we finally support parallel development, right? So this sounds really promising. Why don't we all do this? Well, this idea is based on one fundamental idea, and this one fundamental idea is that we can support fully verticalized systems, right? And everybody who is working in software engineering for more than 24 hours usually knows that this is not the case. This usually doesn't work, right? You want to see some kind of catalog information on the orderings. You want to see some kind of ordering information on your profile. So the front end usually loves to break your service boundaries, right? And the very good example for this breaking of service boundaries is when it comes to a dashboard, right? So let's assume we have a dashboard here now. And on the dashboard, of course, you want to see the latest products, right? You want to see products that could be maybe interesting for the customer. And you want to see also the latest orderings of the user. You want to see what did the user actually order on the dashboard, of course. And you also want to see some profile picture and some name and even maybe some email address, right? So we have all these dependencies again on the dashboard. And if we do this, we usually have, first of all, 2 issues. The first one is overfetching. What do we mean with overfetching? Well, let's say we have a profile with 50 fields, right? With all the stuff we need from a person, we have from a person. So our generic profile services returns the whole 50 fields, right? In the dashboard, we just need the first and the last name, right? So 48 fields from this profile service are useless, right? We uselessly request too much information from the service, but we don't need it in the front end then, right? This is what we tend to call overfetching. And the second thing we usually have then is over-requesting, which means that we have to do a lot of requests to finally get to information which we need, right? So this is usually when people start to play in REST because they need to make a lot of requests to finally get to the meat where they have the information they need. These are 2 issues, and there's again a solution for this, again from Sam Newman. He introduced this backend for frontend pattern. Who knows the backend for frontend pattern? Okay, just a few of you. Okay, that's interesting. Because this is quite usual already in the front end world, in my opinion. What's the backend for front end pattern? The idea is that you build microservices for your front ends, right? So we still have the very generic APIs on our domain service level. So this, let's say, this profile service is again very generic. So it's built for reusability. That different consumers can get information from this profile service. But then in front of every UI, we have our own microservice. And this microservice actually just aggregates the data in a way and provides the data in a way how the front end needs it, right? So we can avoid this overfetching and over-requesting. And this backend for frontend, it's very important to stress here again that in this backend for frontend, we should just put very certain logic, right? Because if we think very abstract of programming, what? Oh. No? No. Yeah. There's no debug mode for this, I guess. I think I cannot shout too loud, actually. Was the last thing you heard? The introduction? Probably not. So if we think of programming very abstract, we usually have a couple of different layers of logic, right? We have data logic where we go to the database, we write in the database, stuff like this. We have domain logic where we calculate the age based on a birth date. We have flow logic where we say we want to call this, and based on this we call this, right? And then we have presentation logic where we get our data, bring it into shape so that the frontend can render it, right? And it's very important that this backend for frontend layer only covers the presentation logic, right? Because if you start to put process logic and maybe even business logic into this, you again have this issue that you build logic especially for front end, and that you cannot really use it anymore. So this is actually a key issue we see today, that people start to put a lot of stuff into the backend for front ends, but the backend for front end is really just the aggregation, right? Just bringing the data into shape that we don't have this over-requesting and overfetching. So usually it's also part of the deployment unit of the front end. So if we deploy front end, we deploy it always together with the backend for front end. We sometimes even have it in the same repository. So it's really part of the front end. It's just the backend side of the front end you can think of. And a new approach, backend for front end approach, is usually GraphQL. We also use this a couple of times already for the purpose of a backend for front end. Of course, you can use GraphQL for multiple purposes, but it turns out to work very good if you want to use it as a backend for front end, mainly because it's more opinionated, right? It doesn't really allow to put you much more information in than just the presentation logic, which is quite cool. So all this sounds promising, right? We solved our overfetching and over-request problem with this backend for front-end pattern, but we still have a couple of issues. And even if we have them, I think it's very important, and I will go to them later, I think it's very important that we stress again that the more coarse-grained you can go, the more coarse-grained you should go, right? And that's especially true for microservices, in my opinion, but it's also especially true for micro-frontends. So don't slice your frontends too small. Maybe start with this hyperlink integration first and start to slice it a little bit smaller later, and we will see the techniques in a minute how we can do this, right? So I tend to tell my clients, think big when it comes to cutting the services into chunks. But, and but is the global word for knowing that everything you hear so far is useless, right? I mean, it's not fully useless, but there's a big but when it comes to hyperlink integration and when it comes to micro frontends. And somehow it's clear, right? We are all building single-page applications these days usually. I mentioned this earlier in the blueprint architecture. I usually see at clients. There was a bubble which was called single-page application. Of course, Hyperlink integration breaks your single-page application, right? That's clear. You always need this round trip to the service, so you lose a lot of a single application. And one good example for Hyperlink integration is actually Amazon. So this is the German Amazon page. I think the one here looks quite similar. And you can see on the left-hand side the catalog, right? Where you can go to all the books, where you can order them, and where you can take a look at reviews. And on the right-hand side, you see the ordering page then, right? And the ordering page is totally different than the catalog page. And who knows the reason for this? Because it's a total different application, right? So they are just linked together by hyperlinks. And if you go to this application and if you really take care of this, you will find out that actually they fully broke the UX and UI here, right? Because the ordering page looks totally different. If you take a look at the buttons, they are totally different. If you take a look at the header, they are totally different. Sometimes even the logos are different, right? So they decided to really make a hard cut here, right? They cut the application into two micro frontends and just connected them by hyperlinks. And the big disadvantage here, of course, is that we lose the smooth user interaction we usually get from single-page applications. But there's a second issue. And the second issue is that we have this view aggregation layer again, right? If we think about this view aggregation layer now, we introduced a second horizontal layer. It introduced an additional horizontal layer. And when we started to do microservices, we wanted to get rid of these horizontal layers, right? Because we wanted to get rid of these horizontal layers, because if you change something here, you need to change it here, and then you need to change it here. And this is what we tend to call the ripple effect, right? And we get this ripple effect back now if we do all this backend for front-end stuff and things like this, because if we take a look, for example, at the dashboard or at the ordering, see that we have again dependencies to multiple services, and we lost this full end-to-end verticalization, right? I was mentioning earlier. So we lose this fully end-to-end verticalization, and this again brings usually issues with bottlenecks, and this usually also brings issues when you want to slice your teams vertical. So if we take back a step now, right? Fully take back a step. I mean, you cannot because you're sitting, but imagine we take back a step now, and we can take a step back now, sorry, and we can start again. What would we actually like to see, right? Maybe it is something like this. Maybe it would be a dashboard service that returns as a dashboard, right? And maybe in the dashboard service we have a profile service which also returns a profile, and maybe then we have a catalog service which returns a catalog, and the ordering service which returns an ordering, right? Want to have the full end-to-end verticalization like this. And there was a talk from Martin Fowler, I think in 2014-15, really the days. I attended once where he already said, actually a microservice should bring its own UI, right? A microservice should ship its own UI. And the whole idea was something like this, right? And if we compare those two approaches now, on the left-hand side, we have this micro-frontend idea of having one micro-frontend per page. This is what some people tend to call micro-frontends. And on the right-hand side, we have this idea of plugging multiple micro-frontends into a page. This is what I meant earlier. We don't have a common understanding what we mean with micro-frontends when we talk about micro-frontends. The left-hand side, I usually don't call this microfrontend. I just call these smaller applications which are linked together, right? It's fair enough. The right-hand side, this is what I usually mean when I talk about microfrontends. I mean, I'm not religious about the term. You can call it whatever you want, but I think it's just important to get this distinction. So let's take a look at the second approach. Let's take a look at this microfrontend approach where we plug multiple frontends into one application. So how do we integrate them? So this is the usual question you will find if you see something like this. How do you integrate those applications into one application? And actually, that's the most high sophisticated slide I think I have on this slide deck. So give it a minute. I think it's quite useful if you want to understand how to integrate micro frontends where you have multiple micro frontends on one page. Let's start with the repository, right? So we have multiple applications in our repository. The first thing we could do is that we could aggregate them all together during build time. We aggregate them together during build time, deploy them once, and if the user hits our application, he just gets the full aggregated bundle, right? That's what we tend to call build time integration. Quite easy, right?
Could you read labels on a string because I cannot see it.
Oh, I should go to this side, for sure.
Just read what's on the slide. That text on the left.
Ah, okay, yeah, for sure. There's the repository layer, there's the build and deploy layer, there's the server layer, so that the edge service. You will understand it if I go to the whole slide, and on the there's the browser. And the second approach would be that we still have these three applications, but we do not. My clicker is. That's interesting. Ah. The second approach would be that we have all our repositories again sliced up into three applications. And once our clients hit our edge service, right? So when the request comes, right? We will do all this bundling on the server side. We will take all these microfrontends, bundle them together, and return again a single frontend. And the third approach, this is what we tend to call server-side integration. The third approach is runtime integration, where we have all those three repositories, right? We ship them independently, so the user can fetch all these independent single-page applications, and the aggregation is done on the runtime, so on the browser actually. So during runtime, this is why we tend to call it runtime integration. And we will take a look at all those three now, just to understand what are the differences, what are the advantages and disadvantages. So let's start with build-time integration. Build-time integration is actually the most easy one, right? Because we actually have a front-end monolith after build and deployment time. It really makes things easy. And what we usually do when we have build-time integration is we do it with a so-called monorepository. Who knows a monorepository approach? Okay, only just a few. How many of you are actually front-end developers? Oh, it's interesting. Okay. Well, then I need to go a little bit into detail about monorepositories. Well, they sound very strange if you hear the first time about the idea of monorepositories. The idea of monorepositories is to put all your applications into one single repository, right? So you put all your applications in one single repository, and the big advantage of doing this is that you can easily reuse code. So you have the possibility to easily reuse code because you don't need to push your button every time you change it to NPM or to Nexus and all the applications need to fetch it. You just put it into one common library. And the thing is that you just have this common library in the same repository, right? So you don't have these round trips all the time if you want to update your dependencies, right? And the second very strange thing about monorepositories is that you usually just have one package JSON, and the package JSON can be seen as the POM XML, for example, where you define all your dependencies. And I mean, this is a precondition for the extensive code reusage, because in this package JSON, you actually define that you want to use Angular 8 now, right? So all your applications need to use Angular 8, and if all your applications use Angular 8, it's easy to share code, right? Somehow obvious. And that's why we tend to do this. And sometimes people ask me, why do we have those monorepos so extensively in the front-end world, but nobody in the back-end ever used them, right? I think the idea is quite clear, because even if we have in the microservice architecture some kind of common lib, usually where we have some logging, some error handling and stuff like this, the usage is quite small in the back-end world, because we actually want to have small usage, because reusage is the highest form of coupling. But in the front end, even if we build more and more high sophisticated stuff in the front end, 70% of what we do in the front end is still UI, right? Is still UI code. And usually one customer wants to have one company to have one look and feel. And this is why we need a lot more reusage in the front end than we actually need it in the back end. And this is why so many people in the back end, or in the front end, sorry, use a monorepo approach. And actually, Google, I think, started this whole idea of monorepos. They do this a lot internally, as far as I understood. So the Gmail application, the Google Maps application, are all living in the same repository. They all have the same package JSON, and in this package JSON they have defined the Angular version. So if they increase the Angular version, they need to increase it everywhere, right? This comes, of course, with the problem of this Big Bang upgrades, but it allows this easy and extensive code sharing and reuse. And if you want to go in the direction, actually, there are really good tools, even if you not work for Google or Facebook. One of them is NRW. It's an extension. It started as an extension for the Angular CLI. It supports more purpose now for Angular and React, and also Express.js, so you could even put your BFF, for example, in the same repository. And the second one is, of course, the Angular workspace. It was introduced with Angular 6, which allows this creation of monorepos directly out of the box for Angular applications, I would say, right? Okay, so this is the build time integration. As mentioned, we bundle this all together during build, and when the user goes to our page, it just gets the whole bundle, right? So the idea is that we just slice it during or before build time. So if we take a look again at the advantages, we still don't have independent deployment. Of course, we need to deploy it all or nothing. We do not have distinct operations, so again, if something fails, chances are high that everything fails, right? We are not technology agnostic. That's the whole idea of the monorepo, to not be technology agnostic, right? Interestingly, it was mainly driven by Angular. But the idea of being not technology agnostic, of course, comes with this advantage that we can have a lot of reusage between our applications. But we have small interface surfaces now, right? So we really have distinct applications. We have distinct React, Angular, Vue.js applications. They are total distinct applications, even if they live in the same repository. So we have those small interface surface. We can model business domains, and the most important part, we finally support parallel development, right? That's why we usually want to do it. And if we say, okay, all this stuff of independent deployments, distinct operations, not important for us, we just want to get faster, we just want to get things done faster, then maybe this build time integration is a good starting point, because it comes with the less complexity you can have at operations and at runtime, but it allows you to at least slice your applications into smaller chunks. So we tended to have quite good experiences with this, and it really helps to get parallelization into the front-end world. Okay, let's take a look at the second one, because I mean, it could maybe get better. The second one is server-side integration. So as mentioned, one client hits the edge service. So once the HTTP request goes to the edge service says, okay, he wants to see the dashboard. So I need to fetch, or I need to actually fetch the profile microservice, I need to fetch the catalog microservice, I need to fetch the ordering microservice, bundle it all together on the server, and return it back as one frontend, right? So the most popular framework here is Taylor from Project Mosaic. It was developed by Zalando, and they did it exactly for this reason, because they said, okay, we want to have full verticalized systems. So how did they do this? Let's take a look at this. So it doesn't really matter if you use Project Mosaic or Taylor or something else, which is based on the idea of server-side includes or edge-side includes. They all do this with these very old concepts. Usually server-side includes, so you can think of it as an HTML page where you just put includes into your page, right? You say, okay, this is the page, and I want to include the stuff which comes back from /products and the stuff which comes back from /payment. So they're all built on the idea of server-side and edge-side includes. And for example, one company which is doing this is IKEA. So if you take a look at the IKEA page, you will see that they actually built up the application based on this idea, and you will see it because they have this big issue of they need all the time. So of course, if you go to the IKEA page and you click somewhere, you always need to reload the page because the bundling is actually done on the server. So you have a lot of round trips. And the second issue, of course, you will get is that JavaScript and CSS are usually globally scoped, and everybody who worked with JavaScript a little bit knows, I don't know if it's a good idea if we put all together these applications, right? And if this JavaScript maybe produces some side effects. So Taylor is a little bit more high sophisticated. So as mentioned, Taylor is a layout server. So let's maybe go back and take a look at how this round trip usually works. So there's a request to Taylor, and Taylor maps this request to a template, right? So in the background, we have those templates. As mentioned, they look similar like those classical old server-side includes. They just call this stuff fragments. So we have fragments, and we say, okay, we want to have the header, and we want to have the account, and we want to have the catalog. And then we can see some attributes like primary. So in this case, the catalog would be primary. So if the catalog returns a 404 because the product isn't found, the whole application would return a 404. And in the account application example, async, so we would not wait till this request is finalized. We would just return a frontend without the account and would return the account later. And maybe we even have a fallback. So if the account microservice is down now, we would just return some static files from some S3 packet, for example. And we have multiple templates. And the idea is that those templates really map back to microservices, right? So we have the header microservice, and the header microservice returns a header. And then the aggregation of all these microservice UIs is done by these so-called templates by fragments, right? So how do they do this? They do this by supporting JavaScript isolation, and that's actually done by a pretty. So Taylor always returns 3 things for one fragment, or always needs 3 things for one fragment. So it's HTML, it's JavaScript, and it's styles, right? So the account fragment would always return a fragment which consists of those 3 parts. Achieve this JavaScript isolation by wrapping the script into an init function and just putting the existing DOM to this init function, right? So we can ensure that we can just access the stuff actually we are allowed to access. So how about CSS? CSS isolation is possible with Taylor. Nobody thinks CSS isolation is possible with Taylor. That's a shame, actually. I'm a big fan of CSS. I didn't want to mention this from the beginning, but actually, I like CSS. And in my opinion, CSS was never the issue. We can isolate CSS already for years. And so we started with something like BAM. Who knows BAM? A couple of you, yeah. So BAM was just a simple naming convention to isolate CSS. Then we have now styled components, mainly in the React world, where we just say, okay, we bundle the components into CSS together and make it unique, that we cannot produce side effects by CSS anymore. We have something which we call CSS modules, or we just add some random stuff at the end of all classes. This is what Angular usually does under the hood. And then, of course, we have web components which come anywhere with isolated CSS, right? So CSS isolation is really not the issue anymore, even if I hear many people always saying, how should we do this? CSS, well, it's usually work. JavaScript is still mainly when it comes to isolation on the server side rendering. So if I look again at the server-side integration, at those 6 points I usually come up with, we now have independent deployments, right? We can deploy our microfrontends fully independently. We can say, okay, we just want to deploy the catalog UI now. And the advantage is that this works, right? So we don't need to synchronize our deployments anymore. We can just deploy one microfrontend, and the bundling is actually done during runtime on the server side. So once the client hits the edge service, the aggregation is done. We support distinct operations. We have seen this with this fallback URL. So if one microservice doesn't reach frontend, actually just keep on going. We can support to be technology agnostic. As we've seen, we somehow could actually even isolate JavaScript. So we could build those frontends into different technologies. We support small interface services. We can model around business domains, and we support parallel development, right? So this sounds quite promising, actually. Why don't we all do this? Well, let's take a look at the last one to finally give an answer to this. And the last one is runtime integration. And runtime integration is usually done something what I tend to call aggregation UI. So we have some UI on the front end which aggregates all the micro frontends. Oh no, come on. This is so 5 minutes, I think, till it pops up again. So runtime integration. We have this aggregation UI, and this aggregation UI actually does what Taylor did in the backend, right? It handles the routing, it handles the templates, it handles the lazy loading. And back in the days, it was done with iframes. So everybody's shocked now, iframes, right? Everybody hates them. But back in the day, it was really done like this. Now we start to use web components, so iframes in cool. And the idea is to get this isolation with web components or iframes. And one framework people tend to use here, and we also tried it a couple of times, but it never really worked out for us, is single SPRs. Single SPR, sorry, the framework is called single SPR, and the single SPR framework actually provides you this aggregation UI. It's quite complex, and we did a couple of prototypes with it, and we always decided to not go for it afterwards, but it's one possibility to get this aggregation out of the box. But of course, you can also build it on your own. So the idea of the aggregation UI is that the aggregation is done on a single point, right? So the routing is done on one point, and based on the route, we fetch some information. We fetch some microfrontends, actually. And then there are people who are very clever, in my opinion. They said, okay, the aggregation and the configuration should be done on a single point. And there's this single immutable web apps. Who knows immutable web apps? Nobody, really. Everybody will learn something here today. That's good. Immutable web apps. The idea of immutable, who knows 12-factor apps? Yeah, all the backend guys, right? Hopefully, yeah. The 12-factor apps it's a very good 12 things you should take care on your microservice architecture. And the idea of this immutable web apps is actually to bring those 12 factors to the front-end world. And they decided to go with this approach where they say, okay, our environment is actually the index HTML, right? So in the 12-factor apps, you usually configure your application based on environment variables. And those immutable web apps, people say, okay, we should actually configure it also like an environment, and the environment is the index HTML, right? So we have this environment for the API endpoint, for example, defined here as a global variable. So all the stuff we use here as application assets, so our application actually is immutable. We just can configure it out of the index HTML. And this is a quite powerful feature you get if you use runtime integration. Okay, we run out of time a little bit, so let's go quickly again. Runtime integration. So we have independent dependencies again, we have distinct operations, we are technology agnostic, we have small interface services, we can model around business domains, and we can support parallel development. So at least after this presentation, you will know the advantages of microservices quite well, I guess, right? Because you heard it a couple of times now. So actually, we have both sides here, right? The server-side integration fulfills all the advantages, the runtime integration fulfills the advantages, right? So which one to use now, right? That's usually the question I get. And I mean, there's no good and bad, there's no black and white. The big advantage of server-side integration is that we still follow this classical request-response model, right? We follow this request-response model we followed for years. You get a request, you return and front-end, right? And the good that the interaction between these verticals is then usually done on the backend, right? Because you have all these requests all the time. Every time you want to have something, you go to the backend. You want to interact between those microservices, you do it on the backend. On the runtime integration, you have these classical single-page applications where you have these long-living UIs, which comes, of course, with a lot of advantages with UX and user experience. So you have all this state in the front and back then, right? So in the request response, we classical have state on the back end. We just have dump UIs, right? And forget more or less. But then we have this long-living state on the front end. The tricky part is then that those verticals actually also need to interact with each other on the front end, right? This is where it can get quite confusing. So I think the simpler approach is the request response model. And if you don't need this long-living UI state and this long-living UI applications where you have the single-page applications, then you could go with this. If you need single applications, you anyway have no choice, right? You need to go with runtime integration. Okay, anything that can go wrong? Unfortunately, we just have 1 minute, so I cannot tell you everything that can go wrong. But of course, I mean, there's a lot of things which can go wrong. If you want to hear more in detail about all the horror stories, feel free to come to me afterwards. I'm here for the rest of the day. So there's a couple of things that can go wrong. Of course, the first one is UI and UX consistency. Unfortunately, I couldn't really talk too much about this one. I have a known talk about UI and UX consistency in microfrontends and component libraries and stuff like this. So this is a huge topic, of course. Shared state is very interesting when it comes to runtime integration. People tend to start to build global Redux stores. People tend to use shared caches. There's a lot of stuff you can do to get this stuff wrong or even right. Resilience is still a big issue, of course, also when it comes to microfrontends. Tracing and analytics, we don't have clear solutions for this, in my opinion. Offline first is anyway not possible. So go offline first, don't build microfrontends, and lots of other stuff. So as mentioned, there is a lot of stuff that can go wrong. So really inform yourself, really take a quite good look if you really want to go this world of microfrontends. And as I mentioned earlier, in 80% of the use cases, you will not really need it, right? And we've seen 4 different approaches, right? The first one, the simple one, where we say, okay, we just size our applications or chunks and integrate them together by hyperlinks. Then we have these things that we tend to call microfrontends, where we have built-time integration, server-side integration, and runtime integration, right? And I do these presentations also from time to time with clients, and then they always ask me, okay, which one to use now, right? Well, I always recommend them this amazing book. Actually, that's the only real answer to this. No, but I don't want to joke, because it's very important to understand now, and I think this is the most important message of this talk, that there is not one approach you should go, right? You should really mix and match stuff here. So take a look again at this Amazon domain, right? Let's say landing page, we have a shop page and we have an ordering page, right? The landing page is 80% of the traffic. 80% of the traffic goes to the landing page. It must be very resilient, it must be very fancy, it must be very good looking, it must be based on the latest standards. A shopping page where we can, where our users can actually buy stuff, right? And then we have an ordering page. And one good approach would be to really cut them into verticals and say, okay, we just connect links. So we can deploy the landing page every 2 hours, right? And we can always stay on the latest React framework, right? But maybe the shopping page is still too big, right? Then a good approach would be here to go for runtime integration, because we want to have this smooth user interaction, right? So runtime integration is quite useful for this. The ordering, maybe it's also still too big, but there we can go easily with server-side integration, because the round trips are not an issue here anymore, right? So really mix and match, sorry, the perfect solution for yourself, and not just go for one approach. Okay, there's a final secret I want to share with you. And this final secret actually says microfrontends are distributed systems. And this sounds very obvious in the beginning, but it's fundamental to understand that microfrontends are distributed systems. And who knows the only real definition of distributed systems? Nobody? Okay, I will tell you. Everything that can go wrong will go wrong, right? And this is also true for microfrontends, right? So maybe, I messed up my best joke. So maybe, as microfrontends are distributed systems, and everything that can go wrong will go wrong, maybe start with a monolithic first approach. Thank you very much. I hope this was useful. So I think we're out of time, but I'm around here. If you have questions, feel free to ask.